So in this section, we're going to be talking about converting between mass and moles and number of molecules and atoms, and kind of bringing all of those concepts together. So here's kind of how we're going to convert between these units. So if you want to convert between grams and moles, what you're going to use is the molar mass, which we talked about in the previous video. And then if you want to convert between moles and particles of a substance, you use Avogadro's number, which we talked about before. And so what this does, remember, we measure things like mass in the lab as a macroscopic quantity, and then we can calculate the particulate quantity by using Avogadro's number. So I think the easiest way for us to do this is to just do examples so that we can see how we can do these problems in labs and also in the homework, quizzes, and tests coming up. All right, so this problem says a certain reaction calls for 0.0540 moles of calcium bromide. How many grams of the compound do you measure? Okay, so we want to measure this out in the lab to do an experiment. So how much do we need to measure? Well, the first thing we need to do is, like we've been talking about ionic compounds and writing down their formulas, we need to write down the formula for calcium bromide. And so we have the calcium ion and the bromide ion. Okay. Once again, we cross the charges. So we have calcium bromide. Okay. That's its formula. And now that we have its formula, we can go in with the problem and do dimensional analysis. So we're given, okay, I'm not going to write out all these steps for all the problems we're going to do in this video, but these are the general steps that we're going to take. So we're given this amount of moles of calcium bromide. We want grams, okay? And for our per expression, well, remember, like we showed here, from going from mass to moles, what we use is the molar mass. So I need to calculate the molar mass of calcium bromide. So we can find how many of each atom we have for the elements in calcium bromide, and then multiply that by the atomic mass found on the periodic table for each element. Okay, so obviously we have one calcium atom here, and this is its mass off of the periodic table. Okay, and then we have two bromine atoms, 79.90. I believe that's right. My handwriting is a little bad in my own notes, so it looks kind of like a 4, but I think it's 79.90 here. Okay, so we add these up, we multiply and then add them up, and you should get 199.88 grams per mole. Okay, so that's my per expression, 199.88 grams per mole. All right, so we're just going to write this out then. 0.0540 moles of calcium bromide times, for every 1 mole calcium bromide, there are 199.88 grams calcium bromide. Okay, so units cancel. Moles of calcium bromide cancels with moles of calcium bromide. And what I get is 10.8 grams of calcium bromide. Okay. And I'm careful here to only include 3 significant figures, okay, using the sig fig rules for multiplication and division here. All right, so that's our first example problem. So let's keep going. Hopefully that made sense. What if I wanted to go the other way now? So now a certain reaction calls for 10.2 grams of calcium bromide. How many moles of the compound do you need? Well, I'm not going to go through all the steps again. So our molar mass here is 199.89 or 88, excuse me, grams per mole. So I'll just write that here. Bromide molar mass equals 199.88 0.88 grams per mole. Okay, so we're just going to use that here. So we're given 10.2 grams calcium bromide. We want moles. Our per expression is going to be for every 1 mole of calcium bromide, there are 199.88 grams of calcium bromide. Okay, so when I write this out in equation form, okay, I get 10.2 grams calcium bromide times for every 199.88 grams of calcium bromide, there's 1 mole calcium bromide. And notice I flipped this expression so that the units of grams of calcium bromide cancel out. And when you plug that in your calculator, you get an answer very similar to the one we had before, 0.0510 moles calcium bromide. Okay, so like I said, there's plenty of examples that we can do and we're going to do in this video. So this should become more familiar to you how we're doing these problems. All right, so here we go. So now, like we said in slide 2, Avogadro's number links the number of particles grouped in moles with the absolute number of particles. So, for example, how many molecules are in 2.0 moles of water? Well, I'm going to do this one a little bit faster. So if I have 2.0 moles of water, remember, for every 1 mole of a substance, in this case water, there's 6.02 times 10 to the 23rd molecules H2O. Okay, so this equals then, when you plug that in your calculator, to the correct number of significant figures, 1.2 times 10 to the 24th molecules of water, okay, or water molecules. So that's our answer right there, converting between moles and molecules. And I went faster through that because we pretty much did the same example in the last or 2 videos back when we were talking about the mole concept, okay? So let's move on. These are, again, just ways for us to get more practice, but also we're going to see something a little bit different as we go on. Okay, so how many hydrogen atoms are in 2 moles of water? Okay, so same idea, all right? I'm just going to write basically the steps that I did before. So 2.0 mole of water times for every 1 mole water. So this did not change. This is the same as the last slide, okay? Whoops. Okay, so we're going to just pause here for a moment. So we want to know how many hydrogen atoms, right, are in 1 H2, or in 2 moles, excuse me, of water. Okay, so let's look at our units right now. So moles of water has canceled with moles of water. So I'm left with molecules. So that means over here, for every 1 molecule of water, I need to ask how many hydrogen atoms are in every water molecule. And there's 2 hydrogen atoms for every water molecule. Okay. So you put this all in your calculator, and now look, the molecules of water have canceled, and I'm left with the units of hydrogen atoms. And what I come up with is 2.4 times 10 to the 24th hydrogen atoms. Okay? So in this case, we went from moles to molecules to the specific number of atoms of hydrogen in the water molecule. All right, so let's continue on. Let's do another example. And why don't you pause the video and do this example on your own, following the steps that we did in the previous examples. And then we're going to do it together. And we're going to go a little bit faster this time. Okay, so assuming you pause the video, let's get to it. So calculate the molar mass of acetic acid. Okay, so it gives us the formula for acetic acid. So to calculate its molar mass, what I need to do is figure out how many atoms I have of each element in the compound. So I have carbon, oxygen, and hydrogen. I have 2 carbon, 2 oxygen, 4 hydrogen. Okay? You look up their masses on the periodic table. Okay. 24.02. Okay, 32.00. 4.04. You take the sum. Okay, and that's going to equal 60.06 grams per mole. And that's the unit, okay, because we're talking about molar mass. Okay, so now with that information, let's do the next one. So these are all going to build on each other, as I hope you've seen as you did them on your own. How many moles of acetic acid are in a 100-gram sample? Well, you can write out, like I did with dimensional analysis, what's given and what's wanted, but just because of the room here, I'm just going to write it like this. Okay, so 100 grams, we'll just call acetic acid acetic, maybe AC, okay, times, well, using this expression here for molar mass, for every 60.06 grams of acetic acid, there's 1 mole of acetic acid. Okay, so when I put that in my calculator and round to the correct number of significant figures, I get 1.665 moles of acetic acid. Okay, so now let's do the next one. Again, they all build on each other. So now we have moles, so now let's calculate molecules. So how many molecules of acetic acid are in a 100-gram sample? And remember, if you go back to that chart, the way we go from moles to molecules in this case is with Avogadro's number. So we already calculated the number of moles in a 100-gram sample, so that makes our life easier here. So we're just going to start out with moles. Of course, if you start out with grams and did the conversion again, you would get the same answer as I'm about to get. So we have 1.665 moles of acetic acid times, for every 1 mole of acetic acid, there's 6.02 times 10 to the 23rd molecules acetic acid. And so I get approximately 1.00 times 10 to the 24th molecules acetic acid when I plug that in my calculator. Okay, so finally, how many carbon atoms are in that 100-gram sample? Well, again, our life is easier here. We already have the number of molecules, so I can convert that directly. Running out of room. Acetic acid times, for every 1 molecule, okay, there are 2 carbon atoms. Okay, and I don't know if I can fit that there, so I'm going to try my best. 2.00 times 10 to the 24th carbon atoms when you plug that in your calculator. Okay, so again, using the steps we learned for dimensional analysis and just doing it step by step, you should have no problem doing these problems here. So in the next video, we're going to be talking about percent composition, but if you have any problems on doing what we did in this video, try the homework on your own, and if you're still stuck, feel free to reach out to me. I'd be happy to help. Okay, so in the next video, we're going on to percent composition. See you there.